Hi everyone, Mrs. V here, and today we are going to be learning about the valence shell electron pair repulsion theory. In this video we're going to stick to molecules in which the central atom has an octet. Well, I can't wait, and neither can you. Let's get into it. Molecules come in many different shapes. In this video tutorial we will limit ourselves to studying molecules in which the central atom has an octet. The shapes we will discuss today are linear, the diatomic type, V-shaped or bent, trigonal pyramidal, and tetrahedral. Remember the Lewis dot cross diagrams that we used when we were studying covalent bonding? They show only the valence electrons. That's the electrons in the outermost shell, which is where the bonding happens. There is a particular way to draw one of these for atoms. We draw the element symbol first. Now we work out from the periodic table how many electrons there are. It's equal to the group number. So let's start with phosphorus. It's in group 5, so it has 5 valence electrons. We're going to add electrons to the top, the right, the bottom and the left, and then once you're at the top again, you can start doubling up. 1, 2, 3, 4, 5. Phosphorus ends up with 1 doubled up electron pair and 3 unpaired electrons. These 3 can make covalent bonds. They're the bonding electrons. The others are called non-bonding electrons. So phosphorus can make 3 bonds. Here, here, here. Pause the video and try bromine. We'll be back soon with the answer. So bromine is in group 7, so 7 valence electrons. Start at the top and go clockwise. 1, 2, 3, 4, 5, 6, 7. We see bromine has 3 non-bonding pairs and 1 bonding electron. So bromine can form 1 bond. If we put phosphorus and bromine together, then 1 phosphorus can bond to 3 bromine atoms to make PBr3. To draw the Lewis structure, we draw the Lewis structure for the central atom. That's the one with the most bonding electrons. In this case, it's phosphorus. Now we line up the bonding electrons of phosphorus with the bonding electrons of bromine. I'm using different colours, but you can use dots for one and crosses for the other. Now we redraw using a line instead of the bonding pairs of electrons. We're still going to show the non-bonding electrons. That's the Lewis diagram for phosphorus tribromide. The atom that we use to name the shape of the molecule is the central atom. It's the atom with the most bonds. In this first example of ammonia, it's the nitrogen. In water, it's the oxygen. In carbon tetrachloride, it's the carbon. We predict the shape of a molecule using the valence shell electron pair repulsion theory. This is usually called the VSEPR theory for short. It states that the electron pairs in the valence shell repel one another as far as possible, and this determines the shape of the molecule. In this video, we are restricting our examples to molecules in which the central atom has an octet, or 4 pairs of electrons. Here's something for you to try. You need a ball of blue tack, or plasticine or dough, and 4 toothpicks. Stick the toothpicks into the ball so that they're as far away from each other as possible. Pause the video, play around with it. What arrangement did you get? If you got this one, you're right. It's called a tetrahedral arrangement, and it's the basis for all shapes of molecules where the central atom has an octet. All we need to work out now is how many bonded and non-bonded pairs of electrons there are in the central atom's octet, and we will know what the shape of the molecule is. If all 4 pairs of electrons in the octet are bonded pairs, the shape of the molecule is tetrahedral. The 4 atoms bonded to the central atom sit at the corners of a regular tetrahedron. The bond angle for any hydrogen to hydrogen in this molecule is 109.5 degrees. Notice the way we show this 3-dimensional shape on a 2-dimensional surface. The shaded triangle indicates that the bond is coming forward out of the screen, and the dotted line triangle indicates that the bond is going back behind the screen. The other 2 bonds are in the same flat plane as the screen. Examples of tetrahedral molecules are methane, carbon tetrachloride, carbon tetrabromide, and silane. If 3 pairs of electrons in the octet are bonded, then the shape is trigonal pyramid, which is sometimes just called pyramidal. The 3 bonds form like a tripod with the non-bonded electrons on top. One bond comes forward out of the screen, one bond goes behind the screen, the third bond and the non-bonded pair are in the same plane as the screen. The hydrogen to hydrogen bond angle is slightly smaller. We're going to discuss that a bit later on. Examples of trigonal pyramid molecules are ammonia, phosphorus trichloride, nitrogen tribromide, and phosphine. What about 2 bonded and 2 non-bonded pairs? This shape is called V-shaped or bent or sometimes angular. The 2 bonds are in the same plane for this molecule. The bond angle is smaller again at 104.5 degrees. Examples of bent molecules include water, hydrogen sulfide, and so on. Let's talk about why those bond angles are getting smaller and smaller. Well, a non-bonded electron pair sits in closer to the central atom's nucleus than a bonded pair because there's no other atom's nucleus pulling it in the other direction. So it repels around a sphere of smaller radius. So it pushes the bonded electron pairs a little bit closer. This happens even more for the V-shaped molecule because lone pairs repel each other even more strongly than lone pairs repel bonded pairs. This is a really strong repulsion. The bonded pairs get squished together even more. One shape to go. When only one electron pair is a bonded pair, the shape is linear. There is no bond angle for this one, as these molecules are all diatomic, and you would need 3 atoms to make an angle. Examples are HCl, HF, any hydrogen halide, the diatomic molecules, chlorine, hydrogen. We also include oxygen with its double bond counting as 1 repelling group, and nitrogen with its triple bond representing 1 repelling group. All these molecules have a central atom with an octet. Their shapes are being caused by repulsion between the 4 electron pairs in the octet. Well, I hope you found that video useful, and if you did, please give it a like and also subscribe to my channel. Get into more videos and learn more fascinating chemistry. I'm going to see you guys in the next video.